In the name of God, in the name of who without doubt is capable and voice, welcome the third episode of learning SAP program. Actually, in this episode, we are going to design and analyze another type of the beam. Actually, this beam is made up of the steel. Actually, in the previous episode that we designed and analyzed the beam, that beam was made up of the concrete. And we learned that how we design a structural element that is made up of concrete. But in this episode, this type of the beam is actually made up of the steel, and it has section of the I-beam. As you all know better that we have different type of the steel section, channel section, we have angle section, plate section, oil section. We have different type of the section, and in our oil section also have different section. The oil is just the ship, and also it means that the oil section have a also we call W section, also we call S section. But the difference is that the W and S section have some slope at the section of, or at the portion of the web, at the portion of the flange, and that slope is equal to 16.7 degree. So now, and the yield stress of this oil beam is 3200 in kilogram meter. Our unit is not in a megapascal. So now we are going to design and analyze this type of the beam, and this type of the beam have two we can say two span. The first span is 3.5 meter, 1 meter, 0.5 meter, and the whole become 3.7 meter. And also the another span is actually 3 meter. In here, in this type of the beam, we have combination of two load, one UTL and the second one point loads. We have the UTL hack at the first span with the amount of 200 kilogram per meter, and also at the distance of 1 meter we have 150 kilogram point load, and at the distance of from this hinge up to here become 1.5 meter. At the distance of 1.5 meter we have 100 kilogram. Okay, there is a not meter. Okay, it's a kilogram. We have 100 kilogram another point load, and then this whole UDL is 200 kilogram per meter, and also this UDL is amount of this UDL is 500 kilogram per meter. Now we are going to design and analyze this type of beam. One thing that you should remember that our goal or our target we discussed in the previous episode, that our goal and our target is that in a analyze portion that we have to find the capacity or strength of our member. But in a design portion, we have to find the best cross section for our member. Now we design this type of the beam with I-beam section, but if their failure comes, it means that this I-beam section is not correct or not enough for this beam element, so we have to change our section. Okay, so how we know that failure comes, or how we know the failure not comes? If we finish all the analyzing and designing, when we design, after that if we see the red color, on that case we know that there is a failure occur. Okay, so what does it mean that failure? If we logically talk about the failure, we have one thing that we should know, that we have K. K is actually coefficient of strength, and the formula of K is equal to P over omega. Okay, what is a P? P is actually pressure, and what's the omega? Omega is actually moment of pressure. Okay, moment of pressure. Now if the K value comes more than 1, okay, you will see the red color. What does it mean? Your section or your beam is failed. You have to change the section. You have to choose another section. For example, channel section, angle section, like this section. But if the K comes less than or equal to 1, Okay, it means you will see another type of the color, for example green, gray, clay. So it means that your beam is actually passed, or you can construct that type of the beam by the eye section. So the main thing is coefficient of strength, P over omega. Another thing from mathematics, we know if the value of P be less than for value of the omega, so you will get the value of less than 1. But if your value of P be more than your value of omega, so in that case you will get the value of the more than 1. So now let's start. So we discussed in the previous session that we have different way to plot our structure elements. So every method that you are, it means that you have a lot of ability to plot, so you can use that method. So in here actually we can use by the specific template of the beam, or we can plot by great spacing, or also we can plot by our own drawing. So now, so no problem which thing that you select. For example, I want to select by grade only. I want to plot my beam by grade only. You can also use by beam. Okay, just two span length. Just in here give the your first span length. Okay, your first span length is 3.7 meter. Then go and by edit grade we can change the data. But also in this episode I want to use grade because less complex. So in that case it will be simpler set for you. So we can use for quick grade lines. So in a number of grade lines mean how many points you have in a x direction. In a x direction we have 3 points. If you see 1, 2 and 3. Then in a y and z direction we don't have any point, but as I told you that you cannot give the value of 0 and minus. You have to give the value of 1. Then grid spacing in here, just give your first space, then we can correct it. So our first space is 3.7. Then y direction we don't have any space, and origin you cannot, so you can get in here, you can give 1, 2, but origin is always 0. So in here we keep these values 0. Then okay. Then we have to draw. How you can draw? You have two options. One by draw frame cable or quick draw. Just click here. Now we have. Then we have to actually create our supports. How we can do? Just click this and click this. Come in a assign, join, restrain. In here select the hinge support, apply and OK. Then at these points also we have 1 point. Okay, so how we can plot the support at the distance of 3.7 meter. In here also we can plot, but it's a middle, but we don't have at the middle support. We have a distance of 3.7 meter. So how we can do? You have to select your member, then come in a edit. So what we are going to do, we have to actually plot a point at the distance of 3.7 meter. Then we select that point and then we change it to hinge support. So select your member, come in a edit, edit lines, divide frame. In here if you see we have last first length ratio. It means your last ratio you have to divide by first ratio. How much distance you get, you have to write here. So our last distance is actually 3 meter. Then 3 and our first span length is 3.7. We get 0.81. Then in here you have to write 0.81. Then apply and then OK. Now if you see in here is a middle. In the middle we don't want to actually apply the lines, okay, or apply the points. Just we have to plot at this distance or at this point. At the if you see at the start we didn't have this point, but now we plotted. So just don't select this, select this. Okay, just select this point, go in a assign, go in a join, restrain and select hinge support, apply and OK. Now, another thing, we finish with the portion of modelization. Then we have to come in a define. In a define, first one we have material. Our material is not from concrete and not from the what we can say, not from the rebar. We can delete these things. Okay, it will not delete because the default we should have one at least. So in here you can add new material. Our material is a type of actually steel. You can change this grade also A36. Then okay, and then okay. The second step, actually we have section properties, frame section. Now in here we have to import the all sections of the I-beam. In here we have to import the all sections of I-beam. And what is the luxury of that work, or what is the goal behind of that work? The goal is that we say to the software that we import all these sections. It means that you have to select from this section one of the best section for our beam. Okay, so now we have to come in and import new property. Our beam is made up of the steel. Then select the I-beam. Okay, now this page will open. Now come in here. In here we have different codes: American Institute Steel Construction, Chinese, Russian, then Europe, Indian. But we have to select sections.pro. Sections.pro, it has combination of the all sections. Okay, so now open. Now we have to select all these things. And HP is also another type of the I-beam section, because it has the shape of the I, so they categorize all of them: W section, S section, HP section, under the one name I section. So you have to select here all of them. And you know what does it mean? For example, in here we have 44 and 248. It means that the first one is 44. It means it's your depth. Your depth is 44 and your weight. And your weight is 248 lb per feet, or you can change it, but in here is lb per feet. Okay, so you have to select all of them, then okay, then in here they insert all of them. Now you have to also sum all these sections under one name. Okay, so come in and add new property, select auto, select list. Then in here, for example, we can give the name I-beam. Okay, then you don't select the first one because a default section from software. So just select these and then add all of them. Now they sum under the one name, I-beam. Okay, now in here, if you see, we insert the I-beam. Okay, if you see I-beam, then okay. Then another option, we have load pattern. We have dead load and live load. In here we have to write the live load, type live, and then add, then okay. Then in here we have to come add load combination, add new compo. As I told you, at the new version we have 1.2 of dead load and 1.6 of live load. But if you design according to LRFD, load resistant factor design, in here we need combination. But if you want to design according to ASD, allowable stress design, is another type of design. So in here you don't need two combination. So but we need design according to LRFD. So we can use the combination of new version 1.2 of dead load and 1.6 of the live load. And you know what is these things? These are actually factor of safety. So here we can write 1.2 of the dead load plus 1.6 of the live load, and then okay. Then we have to assign our section. You have to select all of them, go in and assign. Then in here we have frame section. In here we have to select the I-beam. Okay, then we have to also apply the loads. So first of all, we have to select the first portion. We have to select with the supports. Okay, come in. First of all, we apply the you can apply the first one, the UDL or point load, no matter. So first of all, we can apply the distributed load. We apply distributed load. First of all, select absolute. In here select the live load. we can apply, it was 200 I think, yes. Then apply and okay, and the second one we have UDL of 500. Then in here also at the distance of the 0.5, actually we have 150 kilogram force also, so I have to also select this portion, come in assign frame load, point load. In here we have to add at the distance of the, in here absolute, then at the distance of 0.5, actually we have 150. Then if you see here, then at the distance of 1.5 meter we have 100 kilogram force, another force we have. So at a distance of 1.5 we have another load 100. Okay, then apply and then okay. Now whereas the UDL is still in this member, but if you had another load, it will actually disappear. But for checking, you can come in a display, in here show undeformed shape, sorry, come in a display, in here you have to select all of them. Now come in a display, in here we have an option show deformed shape. On that case you can select all of them, or for another thing you can select this, right click, come in a load. Okay, and if you see we have point force 150, also low point force 100 at distance of 1.5 meter, and also we have another force short force length 200. Okay, it means we have all the type of the loads. Then another thing, in here all thing is finished, then we have to analyze. Set analyze option, XZ plane, okay, then come in a run analyze. Do not run according to model. Okay, as I told you, what is this? Then for example save civil home. Okay, we have to save in here, yes. Then it's actually deformed shape. If you see the animation, now in the previous example when we had concrete, in here for design we come here, but in here for if you come here, this option is off because this is actually made up of the steel, not concrete. So you have to come in a oil or a steel design check of structure. First of all, you have to add your combo or combination. Okay, then you have to design it. So now if you see we don't have any red color, it means we can construct our beam by made up of I section. Okay, now what does it mean W69? It means we have to get the section of the W. And what does it mean 69? So now for knowing of the what is a 69, so come in a define section property frame section. In here find the W 69, this modify show property. Now you have to note all these data and go to market and purchase your I-beam section. Outside height is 0.149, bottom flange weight, actually these are in a meter. Okay, and if you change the unit, for example we change mu in a kilogram millimeter, we can change. Okay, now come in a define section frame section, find your W69. See your data come in a millimeter, flange weight is 100, bottom flange weight is thickness. You have to note all of them and you have to purchase from market. So this is the method that how we can design or how we can analyze the beam made up of the steel. Have a nice time. Good.